Hi, I'm Xin Wang. My project is a video principal component extraction. And as we all know, the extraction, the principal component of a video, is a very important technology in image processing. Not only it can compress the file into a smaller size, but also it can recognize the small feature of a subject from a video. In my project, I mainly use two technologies to process the video. The first, the wavelet transform, and second, the principal component analysis. In short, is PCA. Okay, in the first part, I'll talk about the wavelet transform. The wavelet transform of a signal is calculated by parsing it through a series of filters. The first sample passed through a low-pass filter with an impulse response, resulting in a convolution of 2. As you can see, the y equals to s convolutes the g. And the signal is also decomposed using a high-pass filter H. The outputs give the detail coefficients and approximation coefficients. It's important that the two filters are related to each other, and they are known as a quadrature mirror filter. As we can see, the X is divided into two parts, the H and the G. H is a detail coefficient, and the G is the approximation coefficients. Okay. And I denoise a picture based on the wavelet transform. Using a useful signal usually includes the low frequency part and the high frequency part, whose change is not stable, and the noise signal is usually the high frequency part of the signal. So the signal denoising based on the wavelet transform is mainly aimed at eliminating the high frequency coefficient. As you can see in this image, I photoed it. It's outside of my window. You can see clearly there are many white spots on this image, which is not very perfect for us to extract the principal component. So my purpose is to eliminate this white spot. So here's the basic step of a wavelet denoising. First, wavelet decomposition of the signal. Select an appropriate group to determine the wavelet decomposition level and then decompose the signal into n layer. The layer obtain the wavelet coefficients. Second, solving the closing value according to the layer of the wavelet coefficients. The basic parameter estimates noise and the signal itself, and the noise parameter estimation, so the threshold lambda, threshold precisely. Third, the threshold quantization. Each layer of a frequency coefficients using a threshold value function in conjunction lambda brother threshold quantization. Fourth, wavelet reconstruction. After dealing with the closing value of wavelet coefficients, reconstruct the signal by the algorithm of wavelet transform. Okay, here's the result. The first one is the original image. The second one is a denoise image. As we can see, this picture is much more better than the first one, and the third is denoise the second time. As we compare in the third and the first image, we can clearly see that the third one is much more clear, that there are not so much white spots on the image. Okay, this is a second part of my project, the principal component analysis, PCA. PCA can effectively find the data in the main elements and structure. Also, it can remove noise and redundant, reduce original complex data dimension, simplify the complex data structure. Its advantage is simple, and with no limited parameters, it can be applied with the various situations. Therefore, it's widely applied for from science to computer graphics. It's known as the most valuable result of application of linear algebra. And here is two main features of PCA. PCA is mainly used for data dimension reduction because its characteristics of a series example of a multi-dimensional vector cannot be distinguished. So our purpose is to find those change largely elements, namely the variance of dimension, and to get rid of those little change. And also PCA has a less amount of calculation. Now here is the flow chart. First, we input the original video to get the three-dimensional information matrix, and we deal with the original matrix for two-dimensional matrix. And then we solve the covariance matrix, and then solve the corresponding eigenvalue and vector. Then select the eigenvector corresponding the main eigenvalues. Let's get the input matrix, and in order to reconstruct the video, we transform from the data into three-dimension original video matrix. So here is my result. And the first image is the mean of the first 100 image, and the second image on the left is a principal component of the first 15 image, and the last image is a principal component of the first 100 image. As we can see, compare with the two images, the first one includes much more information. So the size of the first image is bigger than the second one, but the second one concludes the efficient information. So we only need if we have the second image, we can reconstruct the original image. So here is the advantage of the PCA. We extraction the principal component, and we get a smaller size file, which give us much more information. Okay, thank you. Here is a project. Thank you.